Welcome everybody to this ANU Climate Update 2022. It's great to see the interest that we've got. The numbers are still climbing. My name is Helen Cleugh, and I'll be the moderator and chair for the first part of today's update, and I'll explain more about the program later. But firstly, I would like to begin by acknowledging the Ngunnawal people, who are the traditional custodians of the land on which we're meeting today, which for me is in Canberra. I pay my respect to the elders of the Ngunnawal Nation, both past, present and emerging, and I extend this respect to all Aboriginal and Torres Strait Islander peoples in attendance today. And if you wish, you might want to enter in the chat which land you're joining from. So as I said, this is the ANU Climate Update for 2022. This is an opportunity to present an overview of how our climate is changing, both within Australia and globally, and how we're responding to these changes, again, within Australia and around the world. This event brings together an audience of experts, policymakers, students, industry, and the community, so that we can discuss the state of our climate and what can be done to tackle climate change. And we've got a really great lineup of speakers for you today to share these insights with. The program actually will proceed in two parts. The first part will be a summary of the latest climate science, including a snapshot of newly released data on how our climate's changed in 2021. And Mark Howden will be the presenter there, and I'll introduce Mark in a short while. And then the second part, after a short break, part two, we'll discuss the implications of the latest round of the UN climate negotiations, COP26, which were held in Glasgow in November 2021. And those presentations that we have in part two will focus on three issues: targets for emissions reduction by 2030, how we can adapt to climate change in Australia, and what are some of the options for addressing climate change related loss and damage, particularly in developing economies. Now, I just wanted to remind you all, as you can see, this is being recorded, and the recording will be made publicly available on the ANU Institute for Climate, Energy and Disaster Solutions website and the YouTube channel after the event. So if you can only stay for a short time, then you'll be able to go and listen to the recording. Before we get started, just want to talk about how you can engage with us today. So I'm sure many of you are familiar with the Zoom platform. There is a chat function and a Q&A function. If you wish to ask questions, we will have a Q&A session at the end of each part. If you wish to ask a question, please click on the Q&A tab that you can see it. It's probably on the bottom of your screen, and that's where you can go to answer questions. And you can vote for the questions that you think are most of interest to you. And as the moderator, I will use that to decide which questions I ask, as will Rosalind, who will be moderating the second part. Please don't put your questions into the chat window. We've got the chat there because this is a virtual online meeting and we want our audience to be able to engage with each other, but we won't be monitoring that chat window for questions. Please put your questions in the Q&A. And before I go now to Mark, there is one other thing that I just wanted to let you know about, and that is to mention the Aquifer exhibitions. Aquifer is a territory-wide program of dialogue, events and exhibitions responding to the current climate crisis. Local and interstate artists and galleries from across Canberra have joined forces to engage in the climate crisis, and these activities are being kicked off to coincide with this event. To find more information about the suite of activities and when they're happening, please visit the event page on the Institute's website, or you can go to the Belco Arts website, and the link is going to be put in the chat box for you to look at. I will introduce Mark in a minute, but I also realised that I skipped over saying a little bit more about myself, which I'll keep very short. So as I said, my name's Helen Cleugh and I'll be moderating today. I've just recently joined actually ANU as an honorary professor in the Institute for Climate, Energy and Disaster Solutions, which is really exciting. And until late 2020, I was a research scientist and research director in CSIRO, where I remain as a post-retirement fellow. So that's enough about me. Let us now get started to hear from Mark. Professor Mark Howden is the Director of the Institute for Climate, Energy and Disaster Solutions at the ANU. He is also an Honorary Professor at Melbourne University. He's the Vice Chair of the Intergovernmental Panel on Climate Change, the IPCC, and he's Chair of the ACT Climate Change Council. He's served on the US Federal Advisory Committee for their third National Climate Assessment. He's been a member of the Australian National Climate Science Advisory Committee, and he contributes to a whole range of national and international science and policy advisory bodies. He's been a major contributor to IPCC since the early 1990s. Since 1991, he's played a role in the second, third, fourth, fifth, and now sixth assessment reports, and we'll hear a bit about the sixth assessment report from Mark now. And he, of course, shared the 2007 Nobel Peace Prize with the other IPCC participants and Al Gore. So I'll now hand over to Mark to talk to us about the state of the climate. Mark.
Thanks very much, Helen, for that introduction, and thanks everyone for participating in this session today. It's really great to see such a good turn up. Now, I'm just going to cover a lot of ground in a relatively short time, and so I'll just head straight into my presentation. I'm just checking that that's all showing up okay. Fantastic.
As we can see it, Mark. It's good.
Fantastic. So what the key message that I want to comment here is particularly how 2021 was a year of extremes, but also that there is a glimmer of hope that we can actually make good progress in terms of this issue. And the reason why I particularly picked up that image on the right-hand side is that for me, it raises a question of ambiguity. You know, are we heading into the fire, or actually are we heading away from it? And I'll try to answer that as we go through the presentation. So the first thing is just to update you on what's happening in terms of our greenhouse gas emissions. So what we see is that temporary COVID reduction, which happened in 2020, is actually essentially now reversed. So this is a graph coming from the Global Carbon Project, Pep Canadell and colleagues who put this together. And what we see is essentially a almost complete bounce back against that reduction in carbon dioxide emissions that we saw going back during the start of COVID. And my expectations is, in fact, that next year or this year, we will actually be well above the pre-COVID levels because of essentially of the economic bounce back. If we look at our carbon dioxide in the atmosphere right now, it's around about 418 parts per million, compared with pre-industrial levels of around 280 parts per million. And this is the highest it's been in at least 2 million years. As well as record levels of carbon dioxide, we see record levels of methane, nitrous oxide, and other greenhouse gas emissions. So our foot is not off the climate change accelerator. So understandably, given our knowledge about how greenhouse gas emissions translate to increased temperature, we can see that tendency to increase temperatures going over many, many decades. Last year was the 5th to the 7th, depending on the record, warmest year on record, well above pre-industrial levels. Here in Australia, it was a relatively cool year. It was the 19th warmest on record, but still relatively high compared with pre-industrial or long-term records. And in particular, what happened in both the global and the Australian situation was we had a very strong cooling from a La Nina event. So La Ninas are the flip side of an El Nino. And in this La Nina, you can see the sea surface temperature anomalies. Those are the differences from normal. And you can see the characteristic massive tongue of cold water coming out from the Americas across towards Asia Pacific. And what happens under the situations of a La Nina is it tends to cool things down. It obviously cools down the sea surface temperatures, not just in the Pacific, but also in other parts of the world. And also by bringing rainfall to places like Australia, it cools down our land surface. So we see that variation due to the La Nina as a big part of why this year was lower temperatures globally than last year and a few of the previous years. And La Ninas really only operate on an annual or semi-annual basis, and so we can't expect this condition to continue. And so it's likely we will bounce back. If we look at the global pattern of temperatures going for last year, we can see that except for those areas which are affected by the La Nina and also some down around Antarctica, pretty much everywhere continued to be hotter than the long-term average. And in particular, you can see around the Arctic and the West Antarctic Peninsula, there's extremely hot conditions, and they will come into the discussion in slides that I have later. But we can see that tendency to warming continues, and it happens essentially globally with some variation due to La Nina conditions. If we look at sea level rise, which is going up, particularly because of glacial and ice sheet breakdown, but also thermal expansion of the oceans, last year it rose by about 4.5 millimetres, and it continued the acceleration in sea level rise that we've seen over the last several decades. And of course, as well as sea level rise, we're seeing other changes, including acidification of our oceans and deoxygenation of part of our oceans as we get an increased layer of warm water on top of the oceans. And of course, the oceans are the biggest sink of heat across the globe. And what we see when we look at global ocean heat content, we can see that keeps on going up. And again, last year was a record year in terms of ocean heat content. So we're absorbing that heat and storing it away for future decades at a great rate of knots. The next part of my presentation is essentially a bit of a look back at the year, a year in review sort of approach, focusing in particular on climate extremes. That's the theme that I want to communicate here. So for example, if we look in Australia, at both ends of the year, we had heat waves and fires in WA and floods in Eastern Australia, for example, in March and November. So in Perth, it broke the record for multiple days above 40 degrees, and we've had record floods in Eastern Australia. Those fires and heat were experienced in other parts of the globe. Probably the most notable one was the Pacific Northwest, where going back February of last year, essentially this time last year, there was a heat dome effect. So what happens in this heat dome essentially is the polar vortex, the jet streams that used to go around fairly swiftly and fairly stably around the Arctic. Now, because of the increased temperatures in the Arctic, the gradient between the equator and the polar regions has decreased. And so what this means is what used to be a fairly stable polar vortex is now wobbling, and it has big, big loops which extend right down into southern US and Mexico latitudes. And in this particular case, what happened was this loop was essentially really stable, and the inside of that loop was located above Northwest US and British Columbia. And so what that allows is it allows the heat to build up and build up and build up in that location because it essentially captures the air inside that loop. And as a result of that heat dome effect, it shattered previous records in the Pacific Northwest of the US and Canada. And in a town called Lytton, which is about the same latitude as London, it was 49.6 degrees Celsius, the sort of temperatures we experience in places like the northwest of Australia or Death Valley or parts of the Middle East. In a latitude like London. Extraordinary. And of course, it wasn't just the heat. There was accompanying wildfires, problems with water supply, issues with health, overloading of hospitals. And the analysis by the World Weather Attribution Project said that this was essentially virtually impossible without the influence of climate change. And worryingly, in a 2 degrees warming scenario, this sort of event may occur every 5 to 10 years. Of course, fires weren't restricted to that area of the world. In California, further south, the area burnt last year was double the previous record area. And we saw massive fires in the Mediterranean, Siberia, and various other places. On the flip side of that, last February, we saw the Texas power crisis, which has been described as the worst energy infrastructure failure in the history of Texas, and it led to shortages of water, food, and heat. Up to 700 people died unnecessarily because of this, and for a while, around 10 million people were without power. It was the costliest winter event on record, with up to $195 billion damages, and in particular exposed unadapted systems. They called it lack of weatherization, and significant issues with governance, including how energy was priced and the connectivity with other possible energy sources in other states. US was also hammered by hurricanes. So Hurricane Ida was the strongest of them, 114 deaths, 75 billion US in damages. It was the fourth costliest hurricane in the US history and the fifth costliest globally. And it wasn't just the hurricane itself, but the remnants of the hurricane generated tornadoes and flooding as those influences stretched up towards New York. And there's obviously some great images from this, but the one on the bottom left stands out for me, the hazards of taking selfies. We had the European floods, devastating flooding across Belgium and Germany and other places, 220 people killed, something like 46 billion euros in costs. The costliest weather event in Europe to date, shattering essentially the peaceful nature of many villages. Some of those buildings have been there for hundreds and hundreds of years and never experienced anything at all like this. And the devastation, the debris from that was startling. And we had floods in China, extensive and damaging floods from, in some places, essentially a year's rainfall in a day. There was an estimated 400 deaths. Hundreds of thousands of homes were flooded, an evacuation of almost 1 million people. On the other side of it, we had significant science activities, and I'll cover some of the research later in my talk. But in particular, one of the standout science communication activities was the IPCC Working Group 1 report released in August. And a few sort of headlines for me from that report. Firstly, that the human influence on the global climate is now unequivocal. Essentially, it's a matter of fact. It's not uncertain. We can put to bed a lot of that argument that, oh, it's not human influence, etc. It was clear that there was widespread, rapid, intensifying, and unprecedented influence of humans on many different aspects of the climate system, whether it's climate means or climate extremes. In terms of climate extremes, we saw those extreme events more frequent and more severe as evaluated in this report. So human influence is ramping up that pressure associated with climate extremes that I just talked about in the previous slides. I think one of the key messages coming out of the Working Group 1 report is it's clear that we can choose the climate of our future via different greenhouse gas emission trajectories. And Kate is going to talk more about this in her presentation. Essentially, we can choose a climate which is relatively benign and something around 1.5 degrees above pre-industrial. But to get there, we have to go radically off the trajectory we're currently on, which will take us to something more akin to 2.7, maybe even 3 degrees Celsius. And if we're to go on those lower emission trajectories and those lower temperature goals, we have to have immediate, rapid, and large-scale action. And when we look at that report, it is clear that both the existing climate changes that we've seen and the projected climate changes for the future, which vary depending on greenhouse emission scenario, mean that climate adaptation is now unavoidable and it's urgent. And Jamie will talk about that in his presentation in the next section. And just to give you a very small taste of the information in that report, here are 3 panels showing possible rainfall changes at 1.5 degrees, 2 degrees, and 4 degrees above pre-industrial. And we can see that the patterns of rainfall change are fairly consistent across those different temperatures, but the intensity of the change varies dramatically. And in particular, a few points is that what we see is possible areas of increase in the Arctic and the Antarctic and around the equatorial Pacific, but pretty much everywhere else in the world, with some exceptions in Africa and the Middle East, everywhere else gets drier. And in particular, it's those mid-latitudes where Australia sits, which have very strong drying trends, which we're already seeing. But it's not only the mean rainfall that is likely to change, we're likely to see the rainfall variability associated with the El Nino, the ENSO cycle, likely to increase. And I'll cover this a little bit more later in the talk. But essentially, it's the difference between the wet years and the dry years in a place like Australia is likely to increase, with a whole series of implications for droughts and floods and fires. We're likely to see increases in rainfall intensity. So as the temperature of the atmosphere goes up, it can hold exponentially more moisture. And that means when it rains, it can rain in much greater intensities. Some of the examples that I showed you just before. And we're likely to see a strong intensification of the mid-latitude drying trends that we've already experienced, which are drying Australia. In Southwest Australia and Southeast Australia, we've essentially already lost around 20% of our rainfall compared with that of 100 years ago. Another big standout in terms of last year was what happened at COP26, the Glasgow Conference of Parties. And again, a few highlights for me. In particular, we saw enhanced national commitments, with many, many countries increasing their emission reduction commitments, and countries like the US stepping up significantly, 50 to 52% reductions in greenhouse gas emissions. And importantly, we've seen an increase in the update frequency coming out of Glasgow COP. And so annual updates instead of 5 yearly updates, to put the pressure on governments to keep on ratcheting up their commitments, in part because as climate changes, we need to continue to parallel that with our responses. We saw the signing off on the Paris rulebook, which essentially allows us to go into the implementation of many aspects of the Paris, including the global carbon trading system. And that is going to be a really important one for Australia, to ensure that it's a trading system with integrity and to make sure it has social and environmental safeguards in there. It did address loss and damage at COP, but as Melanie Pill will talk about, essentially there was recognition of this, but little action. And importantly, for someone like me, and for many of our listeners today, I suspect, there was a key recognition of the role of science in informing effective policy making. I think a really positive step forward in Glasgow COP. And of course, as side events, there were many other things that came out. And this is only a short list of those sort of commitments and others that arose at Glasgow. There was the Glasgow Leaders' Declaration on Forests and Land Use, pushing countries into more sustainable agriculture and land use management. There was the launching of the International Sustainability Standards Board, essentially the equivalent in environmental terms of the Accountancy Standards Board that governs how we actually run our finances. There was the Global Methane Pledge, with now up to 111 countries signed up to 30% reductions by 2030 against 2020 levels. A significant step forward for this short-term gas in the atmosphere, which allows us to have significant leverage if we can reduce those emissions significantly. There was the Clydebank Declaration for green shipping corridors, essentially to open up shipping corridors so when you have green shipping, they can actually go to a port where there is appropriate green fuel to refuel from. And if Australia doesn't sort of participate in that, it seems very strange, given that we're essentially a maritime trade country. And there was, of course, ongoing discussion of carbon border adjustment mechanisms, including in the context of Australia and Australia's level of action in relation to the Paris Agreement. And essentially, these can put tariffs on Australian goods if essentially Australia isn't complying with what's expected to be our international obligations and our fair share. There's a glimmer of hope for me coming out of the energy transition. What is very clear now is that renewables are the cheapest electricity in history, right across the globe. And of that global picture, as we've seen from various newspaper records, including the one down the bottom, which says Australia power prices are now amongst the lowest in the world. So we're the lowest in the world at the cheapest point of electricity in history. And this puts the lie to many sort of narratives that were told, say, a decade ago, which was renewables were only going to push up prices and they were going to disadvantage Australia. And if we look at the rollout of renewables, last year there was 290 gigawatts of new renewables, beating the previous record from the previous year of 260 gigawatts. We saw businesses coming into this area of activity in a big way, including the Global Energy Alliance, aiming to deliver clean energy to 1 billion people who currently aren't well served by energy sources across the globe. A major step forward, not just for those poor people, but a step forward for the globe. And if we look at the transition in energy sources for transport, now across the globe, 1 in 10 new passenger cars globally are rechargeable. Around 3/4 of those are pure electric vehicles, the others are plug-in hybrids. And Australia is way lagging behind, with around 2.4% of our vehicles being electric. And we saw pretty conservative organisations like the IEA come out and say, if we're to meet the net zero by 2050 goal, there has to be no investment or expectation of new oil or gas and no new coal-fired power stations, putting a line in the sand as to how we need to behave if we're to keep temperatures down to a manageable level. Now, the next few slides look at some of the research that came out in the last year. So looking at the cryosphere, the cold parts of the world, there's increasing concerns about ice sheet stability. Now, whether this is Greenland, West Antarctic, or East Antarctic, all of the signs point to increased instability, and particularly West Antarctica, where that big blob of red was on that global temperature map that I showed you. It's melting fast and destabilizing fast. If we look at Greenland, which continues to lose ice, as you can see from that bottom left-hand graph, which that continue decline in the amount of ice on Greenland as estimated by the GRACE satellites, the gravity satellites, is really problematic. And so we're seeing rapid breakdown of Greenland. And this year we saw the first rainfall recorded on the highest points of Greenland. That rainfall not only melts ice in its own right, but it changes the reflectivity of the ice, enabling it to absorb more heat and therefore accelerate the melt. And as a result, in part of this accelerated ice loss in Greenland, we're seeing the Atlantic overturning circulation, that's the big Atlantic conveyor, at its weakest in at least 1,600 years. Climate scientists have long predicted that would slow down and weaken as a result of climate change, and we're starting to see the evidence come through. So it's now around about 15% less strong than it was in the recent past. If we look at fire risk, a really great analysis by Pep Canadell and colleagues, which looked at how fire risk was changing in Australia. And if we look at the left-hand panel here, the map, we can see that across most of Australia, the fire danger index is increasing and increasing significantly, particularly in the southeast. And if we look at the two right-hand panels, this is the area burnt in the first instance, the fire year, so starting from spring and ending early in autumn, and we can see that's going up essentially linearly. But if we look at the winter period, the autumn and winter period, the cool season, what we see is the area burnt is actually going up essentially exponentially. There is no reason to feel comfortable about how fire is evolving at the moment, and this is beyond the worst case climate change scenarios for this time span, which were produced just a few years ago. And importantly, a lot of our fire danger arises through our climate variability, which in large part is driven by El Nino. So that's the difference between the wet years when we grow a lot of biomass and the dry years where that dries out and becomes an immediate fire risk. And what Wenju Chai and colleagues showed was under the IPCC scenarios is that there's likely to be increased ENSO variability, El Nino, La Nina variability, which will drive increased fire risk across Australia. If you look at agriculture, a really great analysis globally, which replicated what has happened in ABARES in Australia just a few years ago, where essentially the agricultural statistics were used to separate out the technology and management signal from the climate signal. And that's really worrying. What it shows is across almost all of the globe, with the exception of a couple of places in the very north, is that climate change is already driving down potential agricultural productivity. And the only reason why we can still feed the world is because adaptation to those changes and improved management and technology of agriculture is just keeping pace. If we look at urban heat, so urban heat essentially kills more people across the globe than any other climate factor. And globally, since 1983, urban exposure has increased almost 200%. And that particularly affects 1.7 billion people, particularly in those areas, the reds and oranges in the bottom left-hand panel. Now, this increase is happening for a few reasons. One is because it's hotter, and particularly hotter in urban areas because of urban heat island effects, but also because there's a lot more people in our cities, and particularly in developing countries where there's been a big influx from rural areas into those cities. So these authors separated out the warming effect versus the population effect, and that warming effect elevated exposure rates about 52% above those where you look at scenarios of population growth alone. So clearly, climate change is significantly increasing urban heat island exposure for a lot of people across the globe. And this and related studies show demonstrably that locally tailored adaptations and early warning systems are needed. They're needed now to reduce harm, and they will be needed much more in the future. And just to drive home a point which is made in the COVID era, where those arguments that it was either the health versus the economy, you could have one but not the other, is actually a false argument. In COVID, we very demonstrably showed that if you look after your people, you look after your economy. Those countries which acted well and very proactively in terms of COVID also fared well economically. And the same goes for climate change. If we don't look after our people and environment, our economy will suffer, and it's increasingly become clear across a whole range of studies. And if we actually look at the intergenerational implication from these sorts of events, a great headline from a newspaper about a science study by Wim Thierry and colleagues, today's kids will live through 3 times as many climate disasters as their grandparents did. And if that doesn't worry you, then I don't know what will. And of course, if you think that it's all getting a bit hot and you want to go for a swim, climate change is also influencing where the great whites are actually feeding, increasing another risk factor into our decision making. Now, there's other reasons why, apart from those ones that I went through before, for having a glimmer of hope. And this is just the last part of my presentation. There's a lot of pressure coming on all sorts of different entities, governments and companies from the courts. So we see states and cities in the US suing oil companies over climate change and disingenuous communication of the risks associated with it. We see governments in places like the Philippines and Germany essentially being hauled up on the basis of climate change law and action violating basic human rights. In places like Australia, we see class actions and other actions to stop things like coal mine extensions. And we see actions to prevent companies greenwashing their climate activities, hoping to get away with doing very little when they should be doing more. We see investors increasingly stepping up to the plate in terms of climate change action. Things like shareholder rebellions for Shell and ExxonMobil and Chevron. We see BlackRock, the single biggest investor globally, pushing hard in terms of improved climate action through their climate funds, toughening up the baseline activities that are needed to qualify for effective climate action. And we see superannuation funds, big investors in the Australian context, being told that if they don't take climate change into account effectively and don't make effective decisions, instead of outsourcing those decisions, they could be at legal risk. And lastly, we see the regulators stepping up their pressure for companies to take good action. We see APRA and ASIC increasing the pressure in terms of guidance for financial risk management, and also in terms of sending signals about climate change disclosures and the requirement to do that effectively. And this has resulted in various things, including alignment of various portfolios to more effectively address climate change. So I'll just finish here, but just to reiterate the key messages from my presentation. There is increasing reason for concern about climate change. Those climate change extremes which are happening harder and faster. For example, last year was the second worst insurance year on record due to those weather events. We also see glimmers of hope. We see glimmers of hope from government action and business action, and action by the courts and investors and the regulators to drive climate change action faster and harder. But at the moment, that action is not adequate to keep pace with the rates of climate change and increased greenhouse gas emissions and the accumulation of those in our atmosphere. Thank you very much.
Thank you, Mark. We've got some questions, and I'll remind our audience to keep putting the questions in the Q&A. So I'll go straight to those questions now, Mark, but thank you very much for the talk. Really nice to see plain English summary of what the climate science is saying and some of the things that are going on. So yeah, really thank you for that great talk. So I'll start with a question from Michelle, who asks, does the discussion of carbon border adjustment mechanisms amplify the imperative for a global levy on fossil fuels?
I think what it says is that we need to effectively price greenhouse gas emissions. And I say greenhouse gas emissions explicitly because when people talk about carbon, they tend to just focus on carbon dioxide. And there's demonstrably other greenhouse gases which are important. The key argument here is that these emissions of these gases are an externality which is currently not costed into essentially business costs. And by incorporating those real costs into those decisions, we will push down greenhouse gas emissions simply through normal marketplace mechanisms. However, getting agreement to those across the board and in the form of a levy, I think would be virtually impossible politically. And so what has to happen is, to some extent, much softer instruments such as the Paris Agreement, which bring countries in on a voluntary basis and start to set up the mechanisms such as the global carbon market, which can allow efficient allocation of costs and prices across the globe.
Thank you. So I'll keep going. A popular question is, did Australia sign up to the methane pledge out of COP26?
No. And so at the moment, that pledge covers around about 50% of global emitters into the methane emissions. So there's a whole range of quite big emitters which aren't part of that pledge. But arguably, because agriculture is a significant part of our greenhouse gas emissions profile, it's far too big to ignore. Arguably, signing up to that pledge would have not only given us some direction for some of our industries, but it would have encouraged investment in research and development to develop new options that would be both beneficial financially as well as beneficial environmentally in those industries. Thank
you. And another very popular one from Will Howard, question for you, Mark. Notwithstanding the IEA analysis that there can be no new investments in fossil fuels, in fact, as we know, investments are continuing to happen. Many new coal-fired power plants are still being planned and built in developing economies, gas projects, including a number of LNG projects, and new infrastructures such as the Nord Stream gas pipeline in Europe seem to be proceeding. How can these trends be reconciled with the imperative of net zero by 2050?
The short answer, Will, is not easily. And the reason why, of course, these things are happening is because it's in the specific interests, narrow interests of particular governments, rather than in the global interests. And what I think we need to see increasingly is that ratcheting up of the emission reduction agreements and commitments that give much less leeway for these sorts of actions to happen.
Thank you. That was by far, just to say, that was by far the most popular question so far. And there's so many coming in, I've got to make sure I get the good ones. I mean, they're all good, but get the popular ones. So there's one, yes, there's a couple here. I'll go to the climate side just for a few questions for a while, Mark. In terms of fire risk, what might a beyond worst case scenario mean for Australia? How often might we see fires like the devastating ones of the Black Summer of 2019-20?
Well, it's a difficult thing to answer at the moment, and we haven't really put in place the studies that can answer that. But if we look in terms of our rainfall and temperature conditions that were being experienced in the Black Summer, is that they were massive outliers compared with our historical records. So it was the driest on record and the hottest on record by far. And but what we see under climate change scenarios is that becomes a relatively normal condition under our climate change scenarios, say for 2030 and 2050. So the more temperature we push up, the more frequent those sorts of conditions are likely to be experienced. And that, of course, is a grave concern. We all remember the Black Summers and the scars that it's left, and we just simply should not want to go there. We should be taking extraordinary effort to avoid those sorts of futures.
Thank you. Okay, some more on mitigation side. Again, two very popular questions. The first is, what's your view on carbon capture and storage? Not quite sure what's meant by your view, but anyway, I'll let you answer that as you wish.
Sure. So if we look at carbon capture and storage, which is the idea of somehow capturing carbon dioxide and pumping it underground, that's the usual way in which it's framed. There are potentially specific circumstances where that might work. By and large, though, where we see carbon capture and storage type activities working is in things like enhanced oil recovery, where carbon dioxide is pumped down an oil well at one end, so it pushes out more oil the other. So that actually makes climate change worse because you end up burning that oil and producing carbon dioxide. If we, and there's challenges. So carbon capture and storage is really expensive in dollar terms, and it's really expensive in energy terms. So it takes a lot to compress and then inject that carbon dioxide. It's quite expensive in terms of water as well, and we're on average a water limited continent. And lastly, you have to have the right geology to do it. And so oftentimes the place where we're digging up coal and gas and oil is not necessarily the place where you want to bury it. And so that leaves all sorts of issues in terms of transport. There is another way of thinking about carbon capture and storage, and that's linking it into either bioenergy systems, where you have bioenergy carbon capture and storage, or direct air capture, where you can, using chemical and other techniques, capture the carbon dioxide from the atmosphere and then bury it. And in both cases, you're sort of freed from that geology constraint to some extent. And so you may actually be able to design smaller scale systems which actually work and have some benefit. And that latter of those two is already being tried in Iceland, where there's Climeworks have set up a system to use geothermal energy to suck out that carbon dioxide from the atmosphere and inject it underground into the rocks, where it gets locked into the crystal matrix of those rocks and essentially stored forever.
Thanks. That's a nice, helpful response, I think, to explain the technologies. And I'd just add that I think there's also, with the direct air capture, the next step, which is not only capturing it, but then using that carbon dioxide for other materials so that you're offsetting as well. But anyway, I'm going to go to the most popular question now, which is, what actions are needed at the national policy level to achieve the changes we need?
Oh, well, I mean, this comes into highly political territory, and you'll get very different views from different parts of the political spectrum. For me, firstly, there's recognition that climate change is real, that it is of material consequence to Australia and our region, and that it's in our interest to avoid the worst case scenarios. There's very little to be said for going down the worst case temperature scenarios for Australia. We are on the pointy end and the raw end of the deal when it comes to climate change. Secondly, we need to change the narrative, and that's the narrative which frames climate change action as a cost and start to actually think of climate change action as an investment in our current situation and in our future. And thirdly, I think we need to follow what the economics and the science says in terms of things like establishing effective price on carbon and putting in place the research and development that gives us new and better options that allows us to reduce emissions and to adapt to climate change effectively, giving economic and social and environmental benefits from doing so, and establishing Australia as a world leader with great export opportunities, not just through things like exporting hydrogen, but exporting a whole stack of other technologies and ideas.
Thanks. And the next two questions flow from that, actually. So the first one is about, which I think is a great question. Oh, it keeps moving. Here it is. Do you think that the Australian economy energy system has any particular vulnerabilities to future extreme, to future extreme climate events, similar to the Texas energy crisis, for example?
Yeah, so I think there is plenty of vulnerability, but not necessarily in the same way of freezing cold events for Texas. So to give you a feel for why we wouldn't expect that, in Dallas-Fort Worth in Texas, in that cold event, it actually got down to minus 19 degrees Celsius. And this is in a place which is the same latitude as Sydney. So think of Sydney at minus 19, and that will give you a feel for why we wouldn't expect that to happen. But certainly in terms of increased temperature makes our distribution systems less efficient. It makes our solar panels less efficient. It increases demand at times of day where everyone is going to be using electricity. So it puts asymmetries in our system. Changes in water availability, particularly if it goes down, limits our ability to do things like coal-fired power stations, which require water for cooling. Increased disturbance from storms and fires impact strongly on our electricity distribution systems. And so, for example, the South Coast in the Black Summer was in dire straits because when the electricity system went down, the petrol stations weren't pumping, the banks ATMs weren't working, and the mobile phone system in some places went down. So we need to recognise that increased extreme events can throw a big doozy into our energy systems, and increasingly our energy system will be our electricity system. And things like the South Australian connector disruption a few years ago, which threw a big blackout right across South Australia, generated by essentially a tornado which ripped across the power lines. So there's a whole range of ways in which climate change can impact on our energy systems.
Yes, and in fact, South Australia is giving us another example of impact on supply chains with the flooding that we're seeing at the moment as well. So this is a question about science, and you touched on this just before, but from Dorian asks, thank you for your presentation, Mark. Regarding the science, what in your view are the priority areas of further inquiry or study needed? And that's in addition to your comments about bushfire. So, yeah.
Well, thanks, Dorian, for that question. And I think Jamie Pittock in the next session will try to answer that. And he's structuring an argument that says our science focus should change in part from a more predictive focus to a more action focus. And I think there's a lot to learn about how we mount effective emission reduction and adaptation responses. So, for example, the social science work that Beck Colvin and others do here at ANU opens up a whole range of avenues for reducing the barriers and limits to social acceptance of alternatives. So, for me, we need to have an integrated science portfolio which is very action-oriented and which tests different propositions, so we actually learn from those actions, so we can do things better and better, and so we can translate that information to others globally so that they can leapfrog not have to go down the same sort of dead ends that we might go down.
Thank you. And it's disappeared off my screen. Here it is. So Nick Abel, a colleague of ours, how much influence do you think that climate activists like the School Strike for Climate, the Extinction Rebellion, Stop Adani, Lock the Gate, etc., are having, and what is the trend? Again, a very popular question.
Well, the immediate trend, I think, is downwards because of COVID. So what we saw was increased levels of activism and increased levels of acknowledgement of those points of view pre-COVID, and then COVID, because of the restrictions in, say, public gatherings, I think has put the brakes on that heavily. But I think once we come out of COVID and sort of go about more sort of normal interactions, that will re-emerge, as strong or stronger than ever. I think in terms of how it changed the debate, and I've talked with you about this before, Nick. My view is that there's places for many different voices in these debates. It is such a pervasive issue, and there's so many threads in this and so many ways that it influences different groups and individuals across the globe, that we need to have different voices, and we need to respect those different voices and understand where they're coming from, so we can actually improve our own set of responses and our own set of thinking about this. And I think for me, the activists did act as a cattle prod to the levels of action that were happening. They did shine a light on some practices in various parties around the globe and in Australia, which weren't up to speed. I think they did start to change the debate. Greta at the UN essentially ridiculing the ways in which some of the processes were operating and the speed at which they were operating at a global scale. And so I think that school strike and Extinction Rebellion have had an impact, and I think they're a continued and valued voice as part of a spectrum of voices that we need in the future, which includes people like me, scientists, it includes legitimate policy and political concerns, but it includes a whole range of voices from farmers and water managers and banks and regulators, etc.
Thank you. I think you mentioned this in your talk, but maybe not. Someone has asked, they're anonymous, is Australia doing anything about the green shipping corridors?
Not to my knowledge. And yet I would think that this is an option where Australia could establish a major initiative and get a major competitive advantage by looking at this and acting appropriately. And this would require relatively little shift from some of our existing rhetoric about being a massive green hydrogen exporter of energy, to be inclusive of the way in which we export it.
Thank you. And I'm conscious of the time, so I want to make sure there's so many questions, we won't get through them all. I'm going to exercise my moderator's privilege and ask one from Liz Hannah. So Mark, COVID's clearly demonstrated the broad-ranging and hazardous effects on economies when health is sacrificed, yet the expenditure on protecting human health from climate change is minuscule. She says akin to 0.5% of total climate funding. Do you see any appetite for better aligning dollar priorities internationally, A, and B, domestically here at home? And thank you. Thanks for the question, Liz. I think it's a great question.
Thanks, Liz. Really good, and that's why I emphasised the health issues in one of the slides there. It's a hot button issue for many people. Clearly, we're not doing enough in terms of health. It's often hidden, like it's not a well discussed topic, and yet it influences people in their day-to-day lives. And so for me, yes, there's a lot of room to move going up from whatever tiny fraction, a few percent or a few fractions of a percent that we expend on health and ramp that up. But as a general comment is that when we look at expenditure on climate change, the vast majority of expenditure across the globe and in various countries is on the underlying climate science, the global climate models, the oceanographics, the satellites, the global observing systems. And we need all of that sort of stuff. So it's not an argument about cutting down the slice of pie, but only a barest fraction, a few percent, actually gets spent on actions, whether that's emission reduction or adaptation actions, and only the barest fraction of a percent gets spent on things like the social science that enhances adoption, or those health issues which are pertinent to people in their day-to-day lives. So there's a lot of room to move to expand those pieces of pie, but not at the cost of our underlying science. And so we need to have some frank discussions in Australia about what we're doing on climate change and how that relates to things like how the ARC works and the global, the government's expenditure on R&D, which is shrinking year by year. So as a proportion of GDP, our R&D spend keeps on going down, and it should actually be going up, because that's what our competitor partners are doing. That's what our peer countries are doing. They're increasing their spend, not decreasing it.
Thank you. And I'd just add that, there's significant co-benefits too from addressing some of the things like air quality that are affecting health and climate change, as we all know. We're wrapping up to the close. Let me grab. So Tracy Ferrier asks, you said the world is only just able to feed itself by leaning on agricultural adaptation. How long can adaptation offset the effects of climate change, and how would you summarise that level of risk and the time frame for that risk for Australia's producers?
So in the literature which is pulled together for the IPCC Working Group 2 report, the Impacts and Adaptation Report, it's pretty clear that there is limited scope for adaptation. And as we go to the higher levels of climate change, we will not be able to keep up with our current type of agriculture. So with agriculture as we currently conceive it. So we will continue to enhance our management and the technology, such as new varieties of crops, etc. But there's only so much room that has to deliver benefit. And increasingly what we'll be doing is pushing up against the boundaries of what can be managed in a increasingly problematic climate for many parts of the world. But, and I say many parts of the world because, as I showed in that graph, there's some parts of the world up in towards the Arctic where in fact those constraints aren't necessarily the same as elsewhere. And so we'll see a shift in terms of the relative productivity over the next decades. And okay. I should say that shift will be away from the people who most need it and who are often the most food insecure, which tends to be around the tropics and subtropics and equatorial regions, which are the ones which are going to get hammered by climate change and temperatures which are too high and drying conditions.
Yeah, no, good point. Thank you. I'm going to finish with one last question, which I think you'll find very easy, which is that the IPC is about to release its next report. I'm assuming the questioner, this is Tracy again, I've given her two. Oh, that's all right. That'll be the Working Group 2 report. So when can we expect to see that?
So if the approval session goes according to plan, we should see it approved towards the end of this month and launched fairly soon after. So there'll be a sort of a press release which occurs in about 3 weeks' time, assuming that the approval is successful. I think it's probably fair to say that we anticipate this approval session to be pretty tough, and being done completely virtually, it will be pushing the margins in terms of being able to successfully manage the workload that we've got ahead of us.
Yes, it's been an enormous effort by the IPCC community to release these reports, so we're very grateful for that. Mark,
and I should point out, Helen, is that a month after that we've got the IPCC Working Group 3 report on emission reduction, on mitigation. Mm-hmm. And then in October, we should have the release of the IPCC synthesis report, which pulls together all of the reports across this cycle, which includes the climate science, the impacts adaptation, the emission reduction, and the 3 special reports which we've produced.
It's a very, very busy timeline. Mark, if my arithmetic's right, we had about 35 questions and you've answered almost half of them. Thank you so much for your talk, but also answering so many of the questions. And so can we all virtually thank Mark? But I'm also sorry to the audience, there's 408 of you and we just couldn't get to all the questions, but I really appreciate your interaction and the questions, and I really appreciate your thoughtful and articulate response to them, Mark. So thank you very much. And now in terms of today's event, we're going to have a short break for 15 minutes between 4 o'clock and 4:15. So you might want to go and get a cup of tea, but you might not want to, because actually during this break, we're going to be showing some slides. This links back to the Aquifer event that I mentioned earlier. And these slides will show some of the pieces from that exhibition, which has been curated by Nio Fitzpatrick. So that will come up in a moment. But again, that concludes the first part. When we come back at 4:15, my colleague Rosalind Prinsley will take on the role of moderating and chairing part 2, and some really interesting talks there too. So I hope you can stick around for part 2. Thank you, Mark. And yes, we'll see you again in a few minutes.
Thanks, Helen. Thanks, everyone.